What's up, you guys? So today we're going to do Elements of Programming Interviews 13.2, merge two sorted arrays. So we're going to need to write a function that takes two lists and merges the values into A. And I'll explain what M and N are in a second. It'll be easier if I show an example. So say we've got A like this, and A has enough space to perfectly fit the contents of B. So we need to write a function that returns the sorted array of the combined values of A and B. So in this case, 3, 5, 7, 11, 13, 17, 19. And as you can see, B perfectly fits inside of A. So there's a couple of assumptions that we'll make. We're going to assume that A is always greater than B. The len of A is always greater than B. M is the index of the first free space. So in this case, 0, 1, 2, M would be 3 here. N is the len of B, so 1, 2, 3, 4. N would be 4 here. And we're going to assume values of B fit perfectly into empty space in A. Okay, so here's the game plan for this problem. We're going to do the brute force, come up with an inefficient solution, talk about time, space, complexity of it, and think of any ways that we can optimize it. Once we find something good, we'll write pseudocode. We'll talk about time and space complexity. Then we'll give the actual implementation and run it against the test cases. So let's get some intuition about this problem. So, okay, so we've got A and B. In this case, M is this index, and we want to keep track of there's two things we want to keep track of. We want to keep track of the largest element in A, the largest element in B, and also the last free space in A. So we know that the end of A will always be empty, unless, maybe they give us an A that's full and a B that's empty. So maybe that's one edge case that we need to consider, is A has no empty spaces and B is empty. So we would just return A as is. So that's like maybe an edge case we would consider. But assuming that's not the case, we want to keep track of the last element in A, the greatest element in B, and the greatest element in A. So we're going to get the greatest element. We're going to say I equals M minus 1. So this will be I. So let's get rid of M. We're going to say J is going to be the last element and also greatest element in B. And we're going to set K equal to the last element in A. Okay? So let's keep track of this. So J starts off as len B minus 1. K starts off as len A minus 1. Okay, so let's see how we're going to come up with our result. So we're going to compare I and J. So we see 19 is greater than 17. So we're going to set this value to 19. We're going to decrease K by 1. We're going to decrease J by 1. Now we're going to compare I and J again. So now we're going to set K to 17. And we're going to decrease K and decrease I. Okay, so now we're going to compare I and J. We're going to see I is greater, so we're going to set K equal to I. We're going to decrease both. Now we compare I and J. We're going to set K to J because it's greater. We're going to decrease J and decrease K. compare I and j, we set k to j in this case, decrease k, decrease j. Now compare I and j, set k to I because it's greater, decrease I and k. So I at this point is equal to -1 and k is equal to 0. So at that point, maybe we would exit out of one loop and now we would go into another loop to try and finish up the remaining values in our still unprocessed array. Let's think, is that always going to be b? Yes, because the size b is less than the size of a, so if there's only one unprocessed array left, it has to be b. Wait, let's think. Not necessarily. That's not necessarily true, because k could be, I could be out here, I could be out there. I doesn't always have to be less than k. So we need to check whether I could still be greater than, I could be greater than k. So we need to check whether a is finished processing and b is finished processing. So in our case, or in this example here, a is finished processing, and we need to finish processing j. So we finish processing j by just setting k to j, like that. And now we decrement I and k, and we decrement j, and now we return we return nothing in this case. But when we check that a is the correct result, we see that we end up with a sorted array that has merged the values of a and b. So let's think about how we can do this with code. And so I think, so we have to touch every element within a and within b. So this is going to be O of len of a, len of b runtime. And I don't think that we can do better, so I'm going to call this the optimized version, len of a plus len of b time complexity, because we always have to touch every single element in both arrays. And space complexity, we're O of 1 space complexity, because we don't use intermediate data structures. We're reusing the space in A, so it's just O of 1 space complexity. So let's think about some pseudocode. Okay, so let's think. So we're going to set I, j, and k. We're going to say m minus 1 len b minus 1 len a minus 1. See, while I is greater than or equal to 0 and j is greater than or equal to 0, we're going to process both of them, and then when only one is remaining to be processed, we'll process each one individually. Okay, so we're gonna process when both of them remain unprocessed, and we'll process the remainder afterwards. We need to consider whether B is unprocessed with J or A is unprocessed with I. So we'll write code to fill these out, and that should be O of len of A plus len of B. Yeah, okay. And we don't touch any element more than once, so that's good. Okay, so let's think about what we're doing here. Let's reset. Let's go back to where we were at. Our initial example, let's take a look at our example. No. And try and find that example. Let's see if I can remember it. Hold on. It was, oh shit. Oops. Sorry about that. Okay, so what was the example? Okay. No, we gotta find it. I don't remember what it was. Okay. Okay, here it is. Here's the example we're working with. Okay, so 3, 7, 11, 19, and 5, 2, 1, 5, 13, 17, and then 4 empty spaces. 1, 2, 3, 4. Okay, so put I there, or K there, and then I is here. So we're going to run through this again just to figure out what code are we going to do to match our intuition as we merged everything into A. So we're going to compare AI and BJ. So let's bring this up here. And we'll bring it back down once we're done. Okay, so we're going to say, so if BJ is greater than AI, what are we going to do? We're going to set AK equal to BJ, and we're going to decrease these values. So we're going to say K and J equals K minus 1, J minus 1. Okay. So we set K to 19, decrease K, decrease J. Now we compare I and J, and we see I is greater. So now we're going to say else if AI is greater than BJ, what are we going to do? We're going to set AK equal to AI and decrement I in this case, and decrement, so set K to I, decrement K, decrement I. Okay. So let's see if we did that right. So decrement, search for J, replace with K. Okay, so if A is greater, we decrement I and K. So if B is greater, we decrement K and J. It's hard to get that straight. It makes me long for the pattern matching from some other languages. It's a little bit easier to understand. These else if statements, they can trip you up pretty easily, so we'll try and avoid that. Okay, so if neither of these two conditions hold, then they're equal. So what are you going to do when the values are equal? Let's keep going here. So we're going to see, so I is greater than j, so we're going to set k to I. We're going to decrement I and k. Okay, compare I and j, set k to I, decrement k, decrement I or j. Compare I and j, set it to k, set it to j, decrement k, decrement j. Compare I and j, set it to I, decrement both of these. So now I is done. And so we would exit out of this loop. We would exit out of this loop. We'd say, well, j is greater than 0, what are we going to do? We're going to set a, let's just copy this. We're going to set a k, we're going to set k equal to j in this case. And then we'll decrement both of them. Otherwise, let's think, kj. Otherwise, if I is greater than 0, we're going to set ak to ai and decrement I and k. So now we just have to figure out what do we do when, let's say I and j are equal. Let's see if we can think of an example. Let's say so k is here. Say this is 5. Let's say j and I are both 5. Let's say they're both 3. What are we going to do? So we can set the next two values, right? Because it doesn't matter if we set ai first or bj first. So we can just automatically set the next two values because they're equal. So we can say a, let's see here, ak equals ai, that's fine. And then ak minus 1 equals bj. And now we need to decrement these values. We need to, so k, we have set two k values. So we need to decrement k by 2. And we need to decrement both I and j because we've set both of those values. I minus 1, j minus 1. Okay, so let's think about this. Now let's run an example through. Let's pull that example again. So 3, 7, 11, 19, 5, 13, 17. Okay. Let's run through this example. Make sure we know what's going on here. Okay, 5, 13, 17. One, 2, 3, 4. And K's here. J starts here. Okay, so we've already run through this example. So now let's think of what kind of edge cases could there be. Let's say B is empty. If B is empty, we just want to return A. So we could do, that's a simple check. We could say if len B is 0, then return. So we're not returning any, if we look at the function definition, we're not returning any values, but we can skip all the work that we do. We can skip all the work we do by just returning here. So it's It'll save like a small amount of time. Oops. What else? Any other edge cases we can think of? What if what if A is smaller than B? You can't fit all the values of A and B into A. That would be a problem. So maybe we're going to assume we're going to write some tests that would check to see if we have these strange situations. So I think we're good without considering these for now. So let's go ahead and try and run this against some test cases and see how we do. Let's see here. Echo. Not that one. Okay, so we're going to stick in our code that we just came up with. Delete this. Okay, so let's make sure this is formatted right. Go like that. Okay, looks good. Okay, let's run this against some code. Wait, actually? Yeah. Called two sorted arrays. Two sorted. There we go. So Python cur. There we go, guys. So that is, because we touch every element in A and B, it's O of the length of A, the length of B, plus O of the length of A plus the length of B. So O of the length of A plus the length of B runtime. O of 1, oops, space, because we don't use intermediate. Move my head. Don't use intermediate data structures. There we go, guys. So this problem was fun. You know, it's easy to get tripped up. Like, you can mix up A and B and I and J, and I did that the first time. So be careful. Walk an example through your code, and you'll be able to pick up little errors, like maybe you mistake A for B. If you walk through an example, then you should be able to get those errors when you're in an interview. So crush that interview, and stay tuned for the next one, guys.